Hello, everyone, and welcome back. Today, we are going to be talking about the area and perimeter on the coordinate plane. So, let's first talk about how to find the area and perimeter of a rectangle and a triangle. Let's review that. So, let's start with a rectangle. The rectangle is the length times the width. And keep in mind that for rectangles, both lengths are the same and also both widths are the same as one another. So once we know what one length and one width is, we can multiply those. We don't need to find the others because they are going to be the same in the event that it is a rectangle. Then for perimeter, it's two lengths plus two widths. And the reason is that the perimeter is just how much distance is around. So we can think of it as, let's say we're making a rectangular area, a rectangular room, right? How big around is it? Or maybe we're doing a rectangular fenced in area where we're going to keep a garden or for our dogs to play in or something like that. How much fencing do we need, right? We need this much plus this much plus this much plus this much, right? We need two lengths plus two widths in order to accomplish that goal, right? Um, and so that's the idea there of the rectangle. Now let's move on to the triangle. Actually, triangle is a little bit more interesting, so I want to talk a bit longer about that. For the triangle, the area there's two ways to say it. It's either 1/2 times base times height, or you also may have seen base times height over 2. Now, something I want to make very clear is that the height is not always a side length. Okay, the height is the perpendicular distance, it's the altitude, right? It's the perpendicular distance from the end point, or from one of the vertices to the base. So let's say we're going to look at B as the base here. That means that the height is this distance here. Oh, oops. This distance right here that I'm going to highlight, right? It's not actually one of the side lengths in this case. Now, there are some times where it is one of the sides, and that's the case where we have a right angle triangle. If we have a right angle triangle, then the height is one of the sides, right? It's the two sides that are base and height in that situation would be the two legs of the right angle triangle. Okay, so not the hypotenuse, but the two that are surrounding our right angle in our right angle triangle. But in all other triangles, so in acute and obtuse triangles, that's not the case. The height is not one of the side lengths. It's how much vertical distance there is directly from the base to that top point is the height. Okay, and then the perimeter is actually pretty simple. It's basically just A plus B plus C, where we add up all the distances, right? If I was to make a triangular fenced area, though that might be strange, how much would how much material would I need? How much fencing material would I need? Well, I need to, fence in the A part of the triangle, then the B part, then the C part. So just adding up those three is going to get us where we need to go. All right, so now I'm going to do some examples with the coordinate plane. So here it says find the area and perimeter of this rectangle with these points from A to B, from C to D, etc. So what I'm going to do here is I'm going to draw this on the coordinate plane. So let's do that. I would like to know what does this rectangle look like on my coordinate plane? So that's my first step is let's just draw it. So 2, 3 is here. So that's going to be A. And actually, I should also label my axes just for good form. So I am going to label all of this. All right, we'll do, 2, 4, 6, -2, -4, -6, 2, 4, -2, -4. Okay, so that's my point A. It's 2, 3. B is at 2, 6. So I guess 6 would be up there. 2, 6 is B. Then C is -1, 3. So C is right there. And then D is right there, -1, 6. So there's D. And now I'm going to just connect those points. And there is my rectangle, which actually also looks like it's a square as well. But we didn't know that going in. We just knew it was a rectangle. Okay. So they would like to know what's the area and perimeter. Well, clearly now that we've drawn it, we can see that the base and the height are both 3s. And so that's going to help us to find that perimeter. Now, let's say that we drew it and it was unclear to us what the distances were after drawing it. What could we do then? Well, we could use the distance formula in order to calculate the distance and to find the area and perimeter that way. Okay, so that's the other option, is using the distance formula in order to find it. All right, so area is base times height. And in this case, base and height are both 3. So therefore, it's going to be 3 times 3, which is 9. So area is going to be 9 units squared. 9 square units. There we go. And then as for perimeter, perimeter is just all the distances all around. So 3 plus 3 plus 3 plus 3 is one way to do it, or 3 times 4. Or 2 lengths plus 2 widths is the one we have here, so I'll use that. So 2 times the length, which is 3, plus 2 times the width, which is also 3. That's going to be 6 plus 6, which is going to equal to 12 units. So therefore, our perimeter is 12 units, and our area is 9 square units. All right, and let's move on to another one. This one asks us to find the area and perimeter of triangle ABC with vertices -2, 3, 3, -3, and -2, -3. So first thing I'm going to do here is I'm going to draw it, because we might be able to find certain side lengths or an altitude or something like that easily if we do that, or maybe not, but we can at least try our best and see if that's a possibility that we might be able to do here. All right, so let's draw another coordinate plane. There we go. Awesome. Okay, let's label these. All right, so 2, 4, 6, 2, -2, -4, -6, 4. Okay, so A is -2, 3. So there's A. B is -3, or sorry, 3, -3 rather. So 3, -3, which is right there. And C is -2, -3. Okay. So in this case, we're going to just put these together. Okay, so in this case, we have a right angle triangle. We have a right angle triangle. And so therefore, we can clearly see what the base and the height are. Now, the one distance I think we will need to use the distance formula for, or Pythagoras' theorem for, which, same thing. They're very much the same thing, just kind of wrapped up in different ways, is from A to B. It's unclear to me what distance A to B is. However, from A to C, if we just count 1, 2, 3, 4, 5, 6, we can see that it's 6, right? And for this one, 1, 2, 3, 4, 5, we can see that it's 5, right? So therefore, our legs are 5 and 6. So we could either use the distance formula to find the length from A to B, or we could use Pythagoras' theorem. I will be using Pythagoras' theorem today, but either one will work. And honestly, they're very much the same, is the good thing. So a reminder as to Pythagoras' theorem and how we would use it. Well, Pythagoras' theorem states that the two legs of the sum of the squares of the two legs of a right angle triangle is equal to the square of the hypotenuse, right? Or in other words, a squared plus b squared equals to c squared, where c is the hypotenuse and a and b are our legs. So in this case, it's 6 squared plus 5 squared equals c squared, and c is this length a to b here, okay? So therefore, c squared is equal to 36 plus 25. Therefore, c squared is equal to 61. So c is equal to the square root of 61. And the square root of 61 cannot be simplified any further. And so that's as good as we can get it. Okay, so now I'm actually going to go ahead and find the area and the perimeter here. So area is equal to 1/2 times base times height. In this case, the base is 5 and the height is 6. So 1/2 times 5 times 6, which is equal to 1/2 times 30, which is equal to 15, right? 15 is half of 30. So the area is going to be 15 square units. Now, what about the perimeter? The perimeter is just adding up all the side lengths. So 6 plus 5 plus the square root of 61. Now, 6 and 5 I can combine. I can easily say, well, 6 plus 5, that's 11, right? That's 11. But root 61, how do we add that? Well, if you're allowed a calculator and you're supposed to round, you can use your calculator and just type in root 61, which is going to be about 7.8, and then add 11 to that and get 18.8. So this is about 18.8. Now, if you don't have a calculator, then leaving it like this, leaving it as 11 plus root 61 should be fine, right? Because that is the exact answer, and it's not really something we can combine easily because we have a nice round number like 11 with a square root number that isn't even a rational number, right? It's not even something we could make into a nice fraction without having to round at some point, right? Without having to do an approximated fraction here. And so yeah, so that's the approximate. The approximate perimeter would be 18.8, but technically that is rounded. We need technically a little more than that. All right, well, that is everything for today. Great work, everyone, and I will see you next day. Bye, everyone.